Have you ever wondered how engineers decide whether a dam, bridge, road, or retaining wall is actually safe? Many people think we simply open a code, apply a formula, or run software. But before that, good engineers use something called first principles thinking. It means going back to the basic physics of the problem. First principles means not starting with the answer. It means starting with the fundamentals. In civil engineering, we ask, what are the loads? What is resisting those loads? What can fail? And what evidence do we have? Let's take a dam as an example. If we see water coming out near the downstream toe of an embankment dam, the first question is not immediately, which formula should we use? The first question is, where is this water coming from? And is it carrying soil particles? Water always flows from high head to low head. If the seepage path is uncontrolled, the hydraulic gradient may become high. If soil particles start moving, internal erosion or piping can begin. That can become a serious dam safety issue. So instead of only measuring flow, an engineer also checks turbidity, seepage location, piezometer readings, drain performance, filter protection, and whether the seepage trend is increasing over time. Now think about a concrete crack. Many people see a crack and immediately think the structure is unsafe. But first principles thinking asks, why did the crack form? A small shrinkage crack may only need sealing and monitoring. But a crack caused by foundation settlement or reinforcement corrosion may need serious investigation. So the crack itself is not the full story. The mechanism behind the crack is what matters. Another simple example is a pothole. A pothole does not usually appear suddenly. First, a small crack forms in the pavement. Then water enters. The base layer becomes weak. Traffic loads repeatedly push down on the weakened area. Finally, the surface breaks apart. That is why patching the surface alone may not solve the problem. If drainage, base material, or pavement support is poor, the pothole can come back again. First principles thinking is important because codes and software are only tools. They are not a replacement for engineering judgment. If the input assumptions are wrong, the software result can still look professional but be misleading. A slope stability model may give a factor of safety, but did we use realistic pore pressure? A flood model may produce a peak level, but did we check the catchment assumptions? A seismic assessment may say the dam is stable, but did it consider the right components and failure modes? So next time you see a dam, bridge, road, wall, or cracked structure, don't just ask what formula applies. Ask, what is the load? What is resisting it? How can it fail? And what evidence supports the conclusion? That is first principle